AI decides jobs, loans, and care. So who pays when it gets those decisions wrong? AI already shapes big life moments, hiring, lending, and health triage. That power scales fast, and mistakes scale faster. When a loan is denied or a patient is missed, people suffer real harm. Ethics isn't theoretical. It's a set of decisions you build into systems, teams, and policies. In this video, we unpack bias, responsibility, and concrete fixes. First, let's pin down what we mean by AI ethics. AI ethics aligns automated choices to human values like fairness and privacy. It covers both design and use. Designers, deployers, and regulators all have roles. The stakes are legal, reputational, and moral. A faulty model can harm millions in hours. That's why ethics belongs inside product roadmaps and not just in compliance meetings. Next, let's look at where bias actually comes from, step by step. First, biased or incomplete data. If minority groups are underrepresented, models learn the majority's patterns. That produces repeat errors against smaller groups. Missing recent behavior also misleads models when society changes. Data lineage matters. It tells you whose stories are absent. Fixing it can mean collecting more data or designing for robustness. But data fixes create trade-offs, and we'll explore those trade-offs soon. Second, problem framing and labels. Sometimes people pick proxies that stand in for sensitive traits. Zip codes or past spending become de facto proxies for race or wealth. Labels themselves can be subjective. Think culture fit in hiring. If your label doesn't match the real outcome you care about, the model optimizes the wrong thing. That mismatch hides harms until deployment. Up next, measurement errors and model choices that amplify those proxies. Third, measurement errors. Sensors and human annotators differ in quality. Face cameras can misread darker skin tones. Wearables may misrecord on certain bodies. Inconsistent labeling across vendors compounds the issue. These errors aren't subtle. They shift outcomes by race, gender, or income. Solving them requires hardware tests, radar calibration, and clear labeling standards. That leads us to model choices, where innocent math can make unfair trade-offs. Fourth, model choices and training. Teams often optimize for overall accuracy. That approach hides group-level disparities. Loss functions ignore minority errors unless you add fairness constraints. Feature engineering can weaponize proxies accidentally, and hyperparameter choices affect different groups unequally. Those choices are human decisions, not math destiny. Later, we'll show concrete adjustments to loss functions and features that change outcomes in measurable ways. 6. Feedback loops. Predictive systems influence the world they measure. Police sent to certain neighborhoods generate more arrests, which then reinforce predictions. That cycle hardens inequality into data truth. Breaking loops requires intervention and careful retraining. Sometimes you must collect new kinds of data to interrupt the cascade. Stick around. I'll illustrate this with a healthcare case that surprised researchers. Concrete example. A healthcare algorithm used spending as a proxy for medical need. Black patients spent less on care because of access barriers, so the algorithm underflagged them. The result was fewer referrals for extra care for high-need Black patients. Researchers found the bias cut eligible Black patients by more than half. This shows proxies can hide harm in plain sight. Now we'll unpack fairness definitions and why they conflict. Fairness isn't a single outcome. It's a menu of mathematical goals that can clash. Statistical parity forces equal outcomes across groups. Equalized odds equalize error rates between groups. Predictive parity equalizes accuracy of positive predictions. When base rates differ between groups, you cannot satisfy every goal simultaneously. That means you must choose which fairness metric matches your mission. Next, we'll show how to pick and justify a fairness goal for your project. Choosing a fairness goal requires context. For hiring, equalized odds may matter to avoid disproportionate false negatives. For loans, you might choose predictive parity to ensure meaningful accuracy in approvals. Document your choice and explain trade-offs publicly. Measurement is ongoing, not a one-time checkbox. After you pick metrics, establish monitoring and a rollback plan if disparities grow. Next, real-world harms. 5 case studies that shaped public debate. Short answer: responsibility lies with people and organizations, not algorithms. Developers must document choices and test for bias. Product leaders must set fairness goals and fund audits. Deployers must validate models on their populations and train staff. Vendors must disclose limitations and support audits. Auditors execute independent testing and incident response. Regulators enforce laws and consumer protections. Responsibility is shared, but it must be clearly assigned with RACI-style roles. Next, practical steps to assign accountability. Start with a RACI. Who's responsible, accountable, consulted, and informed for each AI decision? Track who owns data quality, model updates, and incident responses. Version everything so you can audit past decisions. Make escalation paths clear when bias shows up. Train human reviewers with authority to override model outputs. Clear roles reduce finger-pointing and speed fixes. Coming up, transparency tools that make black boxes more contestable. Transparency and explainability are not the same thing. Transparency means documenting purpose, data, and limits. Explainability means offering reasons for a specific decision. Contestability lets people challenge outcomes. Tools like model cards and datasheets codify purpose and data lineage. Local explainers like Lime and SHAP show feature importance for an instance. Counterfactuals tell users what changes would flip a decision. But beware, post hoc explanations can mislead if misapplied. Next, we'll point to specific tools and when to use them. Model cards summarize model scope, metrics, and limitations. Datasheets trace dataset lineage and consent status. Lime and SHAP provide local interpretability for tabular and text models. Counterfactuals give actionable reasons, like changing a variable, to reverse a decision. For deep vision models, integrated gradients and relevance propagation help. Combine explainability tools with human review and documentation. No single tool solves explainability alone. Next, how regulation is shaping obligations and what to watch for. Ethics needs operations, not memos. Start with a lightweight checklist you can scale. First, define the decision and worst-case harms. Second, set measurable fairness goals and document trade-offs. Third, curate datasets and document lineage. Fourth, test for bias early and often. Fifth, implement human oversight with real authority. Sixth, provide plain language notice and explanations. Seventh, secure and log systems for audits. These steps form the spine of responsible deployment. Next, we'll expand each checklist item into actionable tactics. For defining decisions, map stakeholders and worst-case scenarios. Use red team exercises to simulate harms. When setting fairness goals, pick metrics aligned to outcomes, then baseline performance. For data, collect lineage and consent, and minimize sensitive attributes unless needed for testing. Bias testing should include distribution shifts and edge case stress tests. Human reviewers need training and clear override authority. These tactics reduce surprise and prepare teams for audits. Next, the explainability toolkit broken down by model type. Pick explainability tools by model type and risk. For tree-based models, SHAP often gives reliable attribution. For deep learning and vision, use integrated gradients or layer relevance propagation. For tabular and text, Lime and SHAP can help, but use them carefully. In credit and hiring, pair explanations with counterfactuals to show next steps. For policy uses, model cards and risk statements are essential for audits. Combine techniques and capture explanation logs for later review. Next, generative AI brings fresh ethical challenges. Generative models unlock speed and creativity, but raise fresh risks. Hallucinations create plausible falsehoods that can mislead users. Prompt injection can trick models into revealing secrets or ignoring safeguards. Generative outputs may reproduce biases and toxic stereotypes. Copyright and consent issues arise from training on scraped content. Misuse risks include disinformation and harmful code. Controls should match task sensitivity. Sandbox prompts, citation mechanisms, rate limits, and abuse monitoring. Next, how ethics becomes a strategic advantage for organizations. If you act now, start with 3 immediate steps. 1. Run a quick bias audit on your highest impact model. 2. Draft a 1-page model card and share it with stakeholders. 3. Assign a named owner with authority to pause deployment. These actions reduce immediate risk and signal seriousness. They also create momentum for deeper changes. We'll close with a concise takeaway and how to stay engaged with this world. Quick takeaway: AI can improve lives at scale, but it can amplify harm faster. Build ethics into systems with measurable fairness goals, clear accountability, and explainability tools. Monitor models in production and prepare incident playbooks. Keep humans where stakes are high and document everything for audits. Make ethics operational, not aspirational. If you want practical templates and checklists, stay tuned to resources we'll link. Finally, consider this question: who in your organization will own responsible AI? Mid-video recap: we traced bias from data to deployment, explored fairness trade-offs, and mapped responsibility across roles. We covered tools for transparency and steps to operationalize ethics. If you've got an AI in production, those checklist items are your immediate playbook. Coming next, resources and concrete templates to use right away, plus a closing challenge to test your team. Resources to use now: model cards and datasheets templates for documentation. NIST's AI risk management framework for governance. Public papers like the Obermeyer study for case context. Tools like SHAP, LIME, and counterfactual libraries for explainability. Standards like ISO IEC 4200 help operationalize governance. Use these as starting points, not final answers. Now here's a closing challenge your team can run this week to test readiness. 3-step tabletop scenario. Step 1. Inject a bias report that shows disparate false negatives. Step 2. Escalate to the named owner and pause high-risk decisions. Step 3. Run root cause analysis and communicate to affected users. Time each step and capture decisions for a real audit trail. Repeat quarterly and after major model updates. Practicing reveals missing logs, unclear roles, and necessary training. Next, final closing and invitation to act. Closing. Responsible AI is a practical craft, not a slogan. It asks teams to design, document, and defend decisions with humility. You'll need technical fixes, process changes, and governance muscle. Start small, measure impact, and iterate. Ethics pays off through resilience, trust, and fewer crises. If you adopt these practices, you'll reduce risk and build better systems. Now here's a simple ask to keep this work moving forward. If this helped, like the video and subscribe for practical AI ethics playbooks. Comment one model your team will audit this week.